Good day and welcome to class. This is Smart IQ. We are going to be rolling on the topic in mathematics today, and that topic is known as sorts. Okay. Uh, Before we talk about this topic, it will be very good for you to understand what are rational numbers. Okay. Rational numbers. Okay. Rational numbers, of course, um, any numbers that can be written as a fraction. Okay. For example, if we have p over q, okay, this is a rational number where p and q, both of them are integer. Okay, both of them are integers. Are we together? Uh, Provided that q is not equal to 0. Okay, so irrational numbers are any numbers that can be written as a fraction is going to be a rational number. Okay, then we have irrational numbers also. Okay, so irrational numbers, irrational, yes, irrational numbers, please. Okay, now for irrational numbers, good. Irrational numbers, on the other hand, cannot be expressed in terms of ratio of integers. Okay, irrational numbers cannot be expressed as a ratio of integers. Okay, and what that means is that we have some. They can be real number, please. Okay, there are real numbers such as your pi, which is approximately equal to 3.142 thereabout. Okay, and your e in Euler is approximately also to 2.718. Okay, approximately. So of course, other examples of irrational numbers can be the square root of 2, okay, and the likes. Okay, so I think we've understood what is rational numbers, okay, and what is irrational numbers. Are we okay? Now let's talk about salt itself now. So what is salt? Okay, uh, of course, the square root of numbers that cannot be simplified into rational numbers. Okay, so sorts are square root of numbers, okay, that cannot be simplified into rational numbers. So let's say we have the square root of 2, okay, uh, the cube root of 4, okay. These are examples of solved. Okay, remember the square root of numbers that cannot be simplified into rational numbers, and we've understood what rational numbers are already. Okay, so we have some basic rules as far as solved is concerned. So rules, okay, uh, of sorts. So let's talk about some of these rules. The first one we are going to talk about, of course, if you have multiplication rules, let's say multiplication rules, that means the square root of A multiplied by B, okay, this will be expressed as the square root of individual element. Okay, the square root of a multiplied by the square root of b. So I've separated the two of them, okay, I think appropriately. So let's put this in a bracket. Are we together? So what that means is that if I have the square root of 3 multiplied by 4, so this is going to be expressed as the square root of 3, okay, multiplied by the square root of 4. Okay, good. And if you have, okay, let's talk about the second rules as basic rules now. The second basic rules. Let's say we have let's call it division now, A all over B. Okay, so this is also going to be expressed as this in a separated manner. That's the square root of A divided by the square root of B. Okay, see that now? And the implication is that if you have something as important as uh, 2 all over 4, and we have to take the square root of that, this means we are going to have the square root of 2 all over the square root of 4. Okay, these are basic rules. Okay, these are basic rules. So if we also have something like this, let's say we have a the square root of b. Okay, remember this is not a cube root, please. I mean, this is not the to the root of a, please. No, that means I'm saying that a multiplied by the square root of b. So this will be expressed as a multiplied by the square root of b. Are we together? So that means if I have 2 root 4, what it means is 2 times the square root of 4. Okay, good. So we move straight to the next. I won't understand this, so let's talk about the next agenda, and that is our basic forms of sword. Okay, so the basic form, basic form. Okay, basic forms of sword. When we talk about the basic form of sword, we are simply saying that how you can get a factors, okay, out of a rational numbers that is in the square root. Okay, you get a factor out of a rational number that is in the square root. Let's say we are to express this in its basic form. Let's say we are to express this now in its basic form. Let's say 18. Good. We want to express the square root of 18 in its basic form. So now I'm going to think of the factors of 18. Okay, and what are the factors of 18? Now I know that the factors of 18, for example, let's say I have 18. Okay, and I want to take the factor. So let's say I have 2, this is 9, 3. Okay, I can as well say 9. Okay, let's say 3, and this is 3, and this is 3. Are we together? So now that means 2, 3, 3, or 2, 3, 9. Good. Let's say 2, 3, 9. These are factors of 18. 2, 3, 6. Okay, 6, 9. These are factors, right? But what of those factors will I multiply to get 18? So that means I'm going to have something like this to the square root. That is 3 times uh, 3 times 2. Good. So having something like this is equivalent to having 9, okay, times 2. Remember? And this is what we have. Good. So coming down, that means we are going to have something like this. 9, okay, times the square root of 2. And the square root of 9, that is equals to 3 square root 2. Okay, so this has been expressed in a basic form. This has been expressed in a basic form. Are we together? Good. Then we move straight to the next very important topic or subtopic under this sword, and that is similar sword. Okay, similar. So we have our similar sword. Okay, what are the similar swords, or what do we mean by similar sword? We can have something like this. let's say A, okay, plus B, okay, and then plus C. Now these are different sort, okay. So these are equal to A, okay, plus B plus C. There's nothing you can do about that. Please take note. So, but if you have something like this, A, okay, the square root of A plus 2 square root A plus 3 square root B and plus 4 square root A. Good. Now, it is very, of course, it can be seen here that we have those guys with A's. So we have this plus 2A's, okay, plus 4A's. These are similar sort, okay, plus 3B, the square root of B. Are we together? Good. So because they are similar, so I can as well factorize them. That means I have 1. That means I have what is common is the square root of A. So I open the bracket. This becomes 1 plus 2 plus 3. Okay. Plus 4, please. Then plus 3 square root B. So this will be equal to square root of A into 1 plus 2, that is 3, plus 4, and that is 7, plus the square root 3 square root B. Good. So now if you get this, remember this becomes 7 square root A plus 3 square root B. Okay, this has been expressed in a simpler form. So similar sort talk about those sort in which the multiples, okay, sword which are multiples of the same sword, okay, multiples of the same sword. Just let's take it. Understand that you can see this is the same, okay. So there are multiples of the same sword, and that's similar sword. Are we together? So they can be added, they can be subtracted. Are we together? They can be added and they can be subtracted. Okay, so the next thing is conjugate. Okay, let's talk about it, and that is conjugates. Okay, this is conjugate sorts. Well, now for this, two swords are said to be conjugates of one another or of each other if their products gives rise to a rational number. So sword A and B are said to be conjugate of each other if their products give rise to what is rational numbers. Okay, now from our knowledge of difference of two square, okay, difference of two square, let's say we have something like this, something very like this, A, okay, uh square minus B square. Okay, this is going to be expressed as A plus B and then A minus B. Okay, now if you open this bracket, let's say we are opening this bracket, let's see whether they are is truly going to be equal. So we are going to have our A, okay, multiplied by A, that is A square, and then we're also going to have A multiplied by minus B, that is minus AB. Okay, then we have our plus B multiplied by A, that is plus AB. Okay, then we have plus B multiplied by minus B, that is minus B squared. So this will strike out, then we ended up having A squared minus B squared. So meaning that these are equal, right? Good. So these are knowledge of difference of two square. Okay, now if we now have something very synonymous, let's say similar in the same way, similarly, okay, in the same way or same manner, let's say we have uh the square root of a, okay, multiply by the square root of b, I mean plus the square root of b, now multiply by the square root of a minus the square root of b. So let's factorize this. Okay, when we do that, so we are going to have this times this, and this will be equal to square root of a square. Okay, and then this times this, that is minus the square root of a, and uh, times the square root of b. Okay, good. This times this, we are going to have, oh, plus, please, plus the square root of a times the square root of b. Okay, let's put them in the bracket so that it will be easier for us. Good. Then finally, this times this, that means minus the square root of b times the square root of b. Okay, good. Okay, so let's say this is what we have, like this. Are we together? Good. So now this uh the square root of a certain number, taking the square uh is of the square root of a number, taking the square of the square root of a number will be equivalent to the same number. That means the square of square root a will be equal to a. Are we together? Now, this is synonymous to what we've done so far. I mean, the basic form. That means I'm going to have a, b. Are we together? Good. Then this is plus what? The square root of a, b also. Then this will be minus. Of course, this will be the square root of b square, which means b. So this will strike out like this, and then we'll end up having a minus b. Are we together? So what it means is that the conjugates, okay, uh, uh, even though the square root of a, okay, plus the square root of b, okay, and that of the square root of a minus the square root of b, you know that both of them they are not rational. Okay, but the product, when we have the product, we got this, which is rational. So what it means is that this and this are conjugate of each other, because the product has provide a rational elements. I think it's clear now. So that's the definition of conjugate sort. So well, let's have an example. So you can be asked to find the conjugate or write down the conjugate of a certain number or certain sword. Let's say this is, we are to write, okay, we are to write uh, the conjugate, okay, the conjugate of uh, the square root of 3 minus the square root of 2. Okay, so now without wasting much of our time, so solution. So if you have 3 minus the square root of 2, so the conjugate, okay, conjugate of this will be equal to the square root of 3 plus the square root of 2. So just change the sign. Are we together? Because we can see that if this, the conjugate must be this before we can get a rational number. Are we together? So what can you multiply by this to get a rational number? It can only be this. So that means the conjugate of this will be equivalent to this. Are we together? So as simple as ABC, let's say you have another one that they want you to find the conjugate, and this one is 1. So let's say number 2, we want to write the conjugate of 4, to the square root of 2, okay, minus 5 to the square root of 5. So, of course, the conjugate of this also, for us to get a rational number, that means the conjugate, okay, the conjugate, okay, must be equal to 4 to the square root of 2 plus 5 to the square root of 5. Are we together? So as simple as ABC. Okay, so and if you take the product, you are going to get a rational number. So before we go today, let us work one more example on that. So you can be asked to simplify. Okay, you can be asked to simplify. Okay, you can be asked to simplify this. So simplify 3 to the square root of 2 minus 1. Okay, and we have another which is 3 to the square root of 2 plus 1. So in another words, that means it's conjugate, right? Good. So if you ask to simplify, how do we do that? Now solution as simple as possible. So let's take the solution of this. So what do we do? So take this to multiply this, take this to multiply this, then this to multiply, this to multiply. That means we have 3 to the square root of 2, okay, to multiply the whole of this. 3 to the square root of 2 plus 1, okay. Are we together? Then minus 1, okay, to multiply 3 to the square root of 2 and then plus 1. Are we together? Good. So if you do that, that means I'm going to have 3 to the square root of 2 square, right? Then plus 3 to the square root of 2. Okay, then we have minus 3 to the square root of 2. Then that is this guy times this, so you are going to have this. Then minus 1 times this, that means minus 1. Are we together? So this square, that means it's 9, right? But the square root of 2 square, that means is 2. Okay, good. Plus 3 to the square root of 2 minus 3 to the square root of 2 minus 1. So that means we have 9 times 2, that is 18. Remember, let's be sure it's mathematics we are doing. Are we together? Good. So this is 18. You can see, so plus 3 root 2 minus 3 root 2 is going to strike out. Are we together? So that means minus 1, and this will give us 17. So to tell us that this is a conjugate, okay, these two Surds are conjugates, you can see that what we have is a rational number, and that is 17. Are we together? Are we together? So I'm going to leave an example, an exercise for you. So you should do that. And this is exercise. So please do that, and you are going to enjoy yourself. I'm sure of that. So that means we have simplify. So you have to simplify. Okay, 2 minus the root of 3. Okay, and 2 plus the root of 3. Okay, so that is exercise. So don't forget, this is smart IQs. Okay, smart IQs. Good. So in case you are not, if you are yet to subscribe to our channels, please do that.